Oh, we got all kinds of boys standing and sitting and maybe perhaps in the prone position, depending on how comfortable you are. Welcome, ladies and gentlemen. I am the Son of Moog. We're about to get started here. These wonderful beats are brought to you by the talented and famous Rob Jansen. So big shout out to him for providing the vibe. Fun talk tonight, guys. Don't know why my camera isn't working. Gotta figure that out. One sec. We're gonna be building a cryptocurrency, and I've actually already technically done all the work behind the scenes. And by the time we get to the end of the first portion of the Tech Talk, we should be able to get you guys set up with a crypto wallet. You'll be able to send your addresses in the chat. And once you send me those addresses, you're going to get some major investments in DOINK Coin. So just bear with me for a moment while I set up my video capture device, which is going to be my web camera. There we go. Everyone loves to see my lovely face. So to get things kicked off, we're going to watch a little video on what are crypto wallets. And then we're going to start diving into building a software wallet. Using a extension in Chrome called MetaMask. I will link out to that extension. If you guys want to follow along and build your wallet, I suggest that you download it while we're watching this. So Mask extension here. And we're just going to throw this in the chat. So you guys can click on that, and that will add to your Google Chrome. Once you have it, you essentially run through the install process. It's fairly straightforward. I have already set up my wallet, so I mean, I could potentially make a new one if I really wanted to, but like, I don't really want to. So hopefully everyone in chat doesn't have any problems. What I will say, if you do have a problem or a question about setting up your MetaMask wallet, pipe it in the chat, and then we're going to get to it. So to kick us off, here's a video on what exactly are crypto wallets.
What is a cryptocurrency wallet? Simply put, a crypto wallet is a tool you can use to interact with a blockchain network. The various kinds of wallets can be divided into three main groups: software, hardware, and paper wallets.
So for the purpose of our demonstration, we're obviously going to be fucking with software wallets.
But depending on their working mechanisms, they may also be referred to as hot or cold wallets. So how do they work? Contrary to popular belief, crypto wallets don't really store cryptocurrencies. Instead, they work as a sort of gateway, providing the tools you need to communicate with a blockchain. In other words, these wallets can generate all the information you need to use cryptocurrencies. Let's take a simple example. Imagine that Alice wants to build a brand new Bitcoin wallet to receive a payment from Bob. The easiest way for her to do that is to use a crypto wallet program. When Alice creates a new wallet, the program generates multiple pairs of public and private keys, along with several blockchain addresses. But to simplify, let's consider only one pair of keys and a single address. First, the program calculates the pair of keys, one public key and one private key. Next, the public key is used to generate a unique Bitcoin address. This is the address Alice needs to provide Bob. Bob then sends Bitcoins from his wallet to Alice's wallet. Note that the coins never leave the blockchain. They are just transferred from one address to another. While it's safe for Alice to share her Bitcoin address with others, she should never disclose her private key to anyone. The private...
Very important. And we actually did this on the last stream. I don't know. Hopefully no one was recording it, but the wallet that we've set up with the test wallet, you don't broadcast the seed phrase. You don't want to tell anyone your password. Basically ruins the whole point of having money.
Key is used for signing new transactions and is what gives access to her funds. So even if Alice loses her computer or smartphone, she can use the private key to access her coin.
So really quickly, a lot of people get hung up on like private key, public key, and like what that means. There's actually a great little video, private key, cryptography with colors. So here's an example. We're not going to watch this whole video, but it provides a very good framework for what happens when you're
After
using
World War II, with most of
public
Europe
and private keys. So we're going to skip to the color demonstration here. Blah, 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 blah. So
that.
here we go.
1. It's easy to mix two colors together to make a third color.
So in the color example, it's keys. You can mix two keys to make a third key, essentially.
And 2. Given a mixed color, it's hard to reverse it in order to find the exact original colors. This is the basis for a lock. Easy in one direction, hard in the reverse direction. This is known as a one-way function. Now, the solution...
And this is essentially the entire core of all cryptography and how it works. So we don't want to get too hung up on the details here, but...
...means in any other device. She may even use a different wallet. But this also means that if anyone gets to know Alice's private key, they can steal her funds. Alice can also use her private key to recover her public key and blockchain addresses. Basically, the private key precedes all the other components, and that's why it's the most important element of a cryptocurrency wallet. In practice, however, most modern wallets make use of a seed phrase. Seed phrases can be used to generate multiple private keys. So, instead of making a backup of each private key in her wallet, Alice only needs to back up the wallet's seed phrase. In other words, the seed
This is what you're going to be doing when you set up MetaMask. You're going to be setting up a seed phrase.
phrase works like a root key. It gives access to all keys and addresses in Alice's wallet. Now that we covered the basics, let's explore the different types of crypto wallets. As mentioned, cryptocurrency wallets may be defined as hot or cold, according to the way they operate. A hot wallet is any wallet that is connected somehow to the internet. For example, when Alice creates an account on Binance and sends funds to her wallet, she is depositing into Binance's hot wallet. Hot wallets are convenient for traders and frequent users because they are easy to set up, and the funds are quickly accessible. On the other hand, cold wallets tend to be a much safer alternative for Alice to store her bitcoins because they have no connection to the internet. Instead, they use a physical medium to store the keys offline, and this makes them very resistant to hackers. This method is also known as cold storage and is particularly suitable for long-term investors. When it comes to the three main groups of crypto wallets, there are software, hardware, and paper wallets. Software wallets come in at least 3 different types: web wallets, desktop wallets, and mobile wallets. A web wallet
So the web wallet is what you guys are going to be setting up with MetaMask tonight.
allows Alice to interact with the blockchain via a browser interface, so she doesn't need to download or install anything on her computer. In contrast, a desktop wallet is a software Alice needs to download and execute locally in her machine. In general, desktop wallets are considered safer than web wallets. Lastly, we have mobile wallets, which work much like a desktop.
So we're not going to be using mobile wallets. or paper wallets or hardware wallets. So we can kind of oh yeah, so how to access MetaMask, I will show you. Great question, Pat. And for asking questions, you're just going to earn yourself some more Doink coin when we finally get you there. So Google Chrome, and I will try and if you look in the top right hand corner of Google Chrome, you'll see that I have this little fox icon here. Chrome does this weird thing where it likes to hide extensions for you. So in order to find it, once you've installed it, you may need to click right here on the puzzle piece, and you'll see MetaMask. In order to pin it, so you see it all the time, hit the pin, you'll see the little fox show up. And then once you click on the fox, you should be able to access and start using MetaMask, okay? You can also, I don't know what other, it's just being super slow. Yeah, I'm going to log into mine shortly, but, oh, you're very welcome, sir. Please ask away as you progress through the chain, because want to get that Doink coin in your wallet as soon as possible.
Top wallet.
Oh, sorry. We're gonna ignore the rest of this video. So while you guys are setting up your MetaMask wallet, we're gonna show a little bit of fun stuff. Actually, we'll do this in Visual Studio. Yeah, Visual Studio Code. So the way that we set up this token was essentially by downloading a set of code from the internet that was provided by an awesome dude who's just like, hey, if you want to build your own, what they call an Ethereum EC20 smart contract, which you can build like tokens into, here's all the code for it, and you just need to modify a few fields. So once you've changed the appropriate fields, so for example, you know, saying like, here's my wallet address, which is important, why we need to know what wallets are, what you want your symbol to be, the name of the coin, the total supply, etc., etc., etc. Once we actually have sort of changed the parameters of this code, we can go into something called a Remix IDE. It is a platform for developing and testing stuff on the Ethereum blockchain. And so what I've actually done here, and you can see, is I've already taken the code, I've loaded it into the application, and it nicely formats everything so I can see all of the fun stuff. Now, for, I guess, the sake of not getting like super technical on you guys right now, once we have modified the appropriate fields and values in this, we should be able to create the coin. Now, what's great is you can also create it in this thing called the Ethereum test network. So let me first, before we get too excited here, I'm going to log into MetaMask. So once I'm logged into MetaMask, you can actually click on the top part of it right here, and you'll see that typically when it starts up, you're connected to the Ethereum mainnet. Sorry, I had a frog in my throat. You're connected to the Ethereum mainnet. That's the main, like, real Ethereum network. You can also connect to the test networks. And what's fun about connecting to the test networks is you can like spin up coins, you can test things, you can play around with it, and it's not using real money. So if I switch over to my test network, you'll see that I've actually set up a couple of smart contracts. I've got some DOINK here, I've got some DOINK here. And once you guys log in, and if you were to set yourself over to the test network, we could transact coin basically for free. One thing that's important to know is that when you are sending coin across from wallet to wallet, that transaction is facilitated by the miners. And in order for the miners to do the work, they want a cut. They want some kind of like payment for that. And unfortunately, because DOINK doesn't actually have any value, you have to pay that in Ethereum. So if I go back to my main net here and I look up my DOINK coin, right, you'll see that I have $3.88 of Ethereum, okay? That means that I'm limited in the amount of DOINK that I can send. Now, I'm going to show you guys how I'm actually going to like top this up and put more Ethereum in my account and blah, 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 blah. But for the sake of this demonstration, once you guys have actually set up your wallet and you're on the Ethereum mainnet, you can click. I'll show you. There's actually a... Where is it? See, it says Mark. That's your wallet address right there. You're going to copy that, and you're just going to paste it in the chat. And it should look like this. That is... Don't obviously use that, because unless you guys want to send me like Ethereum or Doink, like by all means. But once you guys have set up your wallet, you're going to chat me this address, which again, you can find just by clicking here, copy to clipboard, paste it in the chat. And then I can start sending you guys some Doink coin. Let's go into Coinbase. So all of the coin that I currently have in sort of my portfolio, I have mined using an application called Cryptex. So this is all technically free money that I'm playing with. But in order to have some more fun, what I'm going to do is I'm actually going to liquidate my Doge. So let's trade out. I want to get rid of Dogecoin. I want to buy Ethereum. I want to convert Doge to Ethereum. How much do I have? 28.77. All of it. Boom. Okay, so in order to do this, I do need my cell phone, because thankfully these guys use two-factor authentication for this stuff. I missed something. Am I rich now? Not until you gotta send me your address. Once you send me your address, then I can send you Doink. So okay, I have I've converted, which is great. So I should have at some point, once that transaction actually goes through, it usually takes a little bit of, nope, it happened right away, probably because it's internal on their own network, which is great. So now what I'm going to do is I'm actually going to send that 2818 of Doge, and I need my wallet address. So the wallet address is what I send the chat. So just copy this. I say it's going to this address. I'm going to say thanks for the Doink. I'm going to pay with Ethereum, sorry. Thanks for the Doink. Ethereum sending, what was it, 2818, I think. Continue. All right, there's going to be a network fee, a very small network fee. The total is going to be 29.21. Can I do that? We'll see. Yes, that is exactly what I mean, Pat. You're about to get... Just give me 1 second here. Never do this, guys. Never actually show your two-step authentication on... Oh, you don't have enough funds. Oh yeah, because I didn't. So that you have to budget for the transaction fee, right? So I have to say, okay, I know that I don't have. I can send. Let's just send $25. That should be enough to play with. I'm going to send it to this Ethereum address. I'm going to say thanks for the Doink. Continue. It's going to cost me $26.06. Perfect. That's within what I have to send, or to pay, I should say. Jay, we're using MetaMask. It's a Chrome extension. Highly recommend setting it up because it seems to be pretty good at sending and receiving Doink. The link for MetaMask, the Chrome extension, is here. Which take you right to it. Just install it in Chrome, and you should be good. Awesome. Sorry, I need to put this in. Awesome. Doink coins up. Well, yeah, but what's interesting is your wallet isn't necessarily stuck with MetaMask. As long as you know your seed phrase and all that other stuff, you should be good. So transactions usually take about 10 minutes. You see that it's cashed out my Ethereum. And now before I had I have $3.88 currently. Oh shit, sorry, I didn't realize that my fucking face is over my MetaMask wallet. Why didn't you guys tell me that? Jesus Christ. Okay, so Pat, we're gonna send some Doink to Pat. Pat followed, which I think I said 100,000. I just want to make sure I got this right. Yep. So I think I said 100,000 for the follow, at least, and then Yeah, no, we're Pat. You know, just because I respect you so much, we're gonna bump that up to 200,000. Okay, 200,000 doink coming your way. So that is right? Yeah. Okay. So I am going to send. Well, Pat's just a professional dude. Don't blame him. Copy this. I'm sending this. We're sending doink. I'm going to send 100,000 or 200,000, I should say. 2,000. I'm gonna send it slowly because it's gonna cost me $1.95 to send this to Pat. Boom. Here we go. All right, confirm. So you'll see that the transaction is now pending. Now, what's exciting about this, guys, is where the fun shit really happens. And Pat, check your browser. You should have just received some Doink coin there. What's really exciting about this is we can also play on the Ethereum test network, and there are no transaction fees. So if we actually want to use this currency in a ridiculous way and constantly trade it back and forth with no actual like real world funds put into it, then we can do it that way. So let me, oh, nice video link. All right, we'll pull that up in a second. Jay, I think we're going to send you some here too. So send some doink to this address. You're going to send, you know what? Jay's getting 200,000 too. Okay. Send it slow. Next. Confirm. Done. Now, if we go back to my wallet, you'll see that I have 23 bucks in here because that transaction from Coinbase already kicked through. My fucking portfolio is kind of tanking right now, but that's just because I'm having a lot of fun playing with cryptocurrencies, guys. So it looks like transaction confirmed. So I think if you guys check your wallets, you should see that. Oh, so let's dive in a little bit deeper here because this is kind of fun. So I can actually go into my activity, right? And I can see if I click view on Etherscan, it says success from here to, wait, that doesn't make sense, does it? Jay, did you get any coinage? Let's see what happened. It says success, but why do I feel like this is the hold on. It should take a minute. Yeah, but you guys should see it pretty quickly. This was my account is back. Okay, we're gonna try this. So if I go back to actually one of the things you can do, guys, too, if you don't like fucking around the extension, you can click here and go expand view, and it actually opens up in a tab properly for you. Okay, let's go to Pat's transaction and view this on Etherscan. You end in 435. Okay. So it came from me, which is that's right. Interacted to, yeah, that should be right. Okay. And then there we go. Oh yeah, Matt, I don't think it works on I don't know if it'll work on a cell for you. I think you might have to be on a laptop, to be honest. Well, the work shouldn't take any time because the work's already gone into it. It says, like, it confirmed the block. So I wonder, am I fucking something up here? Or am I just am I sending, like, random fucking Doink coin transactions to poor people? Let me see something here. So this is from... me? No. Well, this is the part, I think this is the part, Pat, that might disappoint you. We don't. It's more of a token. It's kind of like a, whatchamacallit. It's like a it's like Pogs. It has about as much value as a Pog might, which is basically 0. Oh yeah, no, I hear that. Okay, here's Jay's. So I got Jay's wallet. Okay, let's just go back through the transaction really quickly here. So, according to this, this one was D7. Did I get the address wrong? Is that why? Because 53A is me. D7. Okay, I must have fucked this up. Maybe I'm sending random people DOINK coin, which is even fucking better. I think that's like the best way to do this, if possible, actually, guys, is just send DOINK to the wrong people. Okay, so new address detected. Interesting. Okay. This is 4-5. I'm gonna send you because of the transaction. I'm gonna say 300,000 because I feel bad for the mistake. So we're up in the ante here. So this is going to Pat. Hopefully this works. And now we're going to go to the transaction. We're going to watch it live in Etherscan. Okay, that's interesting. Maybe it takes a second. Sorry. Okay, this is kind of fucked up. Wait, guys, maybe DOINK Coin's getting hacked right now. I don't know what's going on. Jay, I'm gonna try and send you some too. Here we go. New address detected. Yeah, DOINK. I think that's 3 million. It's too much. Too much. I gotta be the biggest DOINK holder right now. Okay. So DOINK. Okay. Yeah. Oh, there you go. It's pending. So we can watch it live. You can see it'll take between 2 and 16 minutes. This is how long it is. It's coming from me. It's going to the contract. Pending transfer to 4-5. So this should be going to Pat. This is Pat's transaction here. This should work. So we just have to wait, basically. And another thing too with cryptocurrencies, because the way, especially there's a serialization to it, so I cannot send this DOINK until this DOINK processes. So you just gotta wait a little while. But on the test network, like if we actually switched over, and I sent you, let's say, like, I don't know, 1 billion of the other DOINK, I think your wallet is the same. Hey guys, do me a favor. If those of you in chat, switch from your Ethereum mainnet, change to the Ropsten test network, and tell me if your address stays the same. I think mine does. Yep. Same. Okay, sick. So, for example, to just show you guys, so in the Ropsten test network, if I go to my assets and I go, so I have actually made a bit more DOINK, I think, in this one. So for Pat, I'll send you, I don't know, 2 billion DOINK. Sure. Next. Done. J. Send DOINK. I don't know. Next. Boom. And then again, I can wait on the test network and see what happens. So this will put, so the other cool thing too is if you guys, I can send you guys Ethereum too if you want, but you can actually use something called a faucet, and faucets will inject your test accounts with would the next transaction lose value at the market while waiting, or would it hold at the so that's actually a really interesting question. And this is where things kind of are a little fucked up. So the value of a cryptocurrency changes from moment to moment, but the unit of measure of cryptocurrency does not change. So yes, the value of it like could increase or decrease in like 30 seconds or whatever, right? Depending on what's going on in the market, but you're still transacting the exact same like physical, or like the amount of actual coin that you're transacting is the same. So if you're sending one ether, you're gonna get one ether. That ether might be worth something a little different depending on it. There's also ways to speed up transactions, right? So you can pay money, you can incentivize miners and say, hey, like I'll show you an example, right? So if I make, let's actually go to Solidity real quick. This is something I learned like fucking all of this up for like the longest time. So if I go to DOINK Coin and I actually want to compile it, and then I can go to, so I'm gonna try not to lose you guys here. Hopefully I don't go too fast. Solidity on the right is able to interact with MetaMask as an application. If I select injected Web3, it can actually detect that I'm on the Ropsten network. That is my Bitcoin address, and here is the the code essentially that I want to deploy, or the contract that I want to deploy to this test network. Now, if I go to here, and depending on what I set as like the gas limit and the value of that gas limit, that is what that essentially determines how much miners are going to charge me to process my transaction on the block. So if I take a very small, like if I make it very, very small, oh, by the way, did you guys get your coins, the Pat and Jay? Let me check to see if the Ethereum name, oh no, sorry, it's still pending. It's still pending. Oh, no, it looks like it went through. One of them went through. God damn it. It better, if it doesn't, if I'm just sending like random doink to people, this is going to be the biggest like fucking like mistake of my, oh, it says it's done. That's interesting. Success status 2 minutes ago. 2, 4, 5, yeah. Maybe it does take a minute. I wonder, is it because you guys don't have like money in your wallets? That can't be why. Because it's charging me the transaction fee. It's not charging you guys the transaction fee. Anyway, what I was going to show you is that if you did have a pending transaction, like it says for whatever reason here that I shouldn't have one, you can speed it up, and I can go here. It says, well, here's the estimated processing times. How much do you want to spend? And I'm like, okay, so I could click 169. You should, Pat, you might need to refresh. And what you really want to do is you want to check your activity to see, like, it should just show up. And oh, you know what you guys might need to do, actually? Hold on. I wonder if you need to add the token. Try... That's my address. What is the address of the contract? I think it's this. Yeah. So here, what happens? Yeah. Try adding a token, and if you click add token, I'll show you how to do it. So if you click here, add token, go to custom token, and when you paste this in, it should already populate the token symbol, the decimals of precision. Okay, so let's see what happens when you just add the token, and if it shows up in your pool. Because if that's the case, then like you guys might have got like just it picked up the name Doink. Okay, so when you click add, does it show a balance? Do you guys have a balance of Doink now? I really hope so. That'd be so sick. Matt, Let me see if I might not have sent it to you yet, Matt. Let me try again. I'll give you. Okay. All right. So I've got 2 transactions queued up. This one has to happen. So I'll show you guys. This is a real world example of Jay. Did it show up? Yeah, it showed up. So sick. All right, all right. So this transaction completed. That transaction just went through really quickly. I think this one's going to go through pretty quickly too. And then I think Matt, your transaction's next. It's coming, buddy. It's coming. You don't search for the token. I'll show you, buddy. You go here, click add token, and click on custom token. And when you see custom token, paste this address into the custom token. And it should populate this as DOINK, and then this is 2. Oh, I can't, honestly, guys, like, just a quick call out. Neil is missing out big time. there's a huge miss out alert. I know the man's busy. He's got stuff to do, but like, come on. What a doy. Matt, hold on. Your transaction I don't think has gone through yet. I gotta yeah, it's still pending. Right? So guys, here is the problem though. Here's the problem. You cannot send DOINK without having Ethereum. Now, what I think we should do, and what I'd like to get you guys to do, is if we don't use the Ethereum mainnet and we switch over to the test network, I'll show you how fauceting works, right? Ethereum faucet. Here we go. So check this out. So I put in my test thing, right? And I say, hey, send me test ether. Watch this. Cool. Test ether sent to So now when I go to my wallet on the test network, I'll expand this so you guys can see it really well. You'll see this. This should go to 1.99 shortly. Now, once that happens, then I've got tons of ether and I can send you guys a whole bunch. And then we have shit tons of money to send coin. I personally think that we should use the test network for all of the fun stuff, but the real coin exists on the actual blockchain right now. So, again, if I go, because you can see I've only got like $20 here. Now, let's say I want to speed up this transaction because it's taken a little longer than I'd like to. I can actually go back and say, I really want Matt to get his DOINK coin. So I'm going to speed up the transaction. I'm going to pay an extra $1 here. You can't, not yet, Matt, not until we figured it out. Failed transaction. That's fucked up. What happened? Interesting. Yeah. That's kind of that is kind of the idea. Oh, it looks like it went through. Interesting. So, confirmed. Yeah. So transaction 9 confirmed. So Matt, you should get DOINK in your account shortly, once you've added the token. See, now I've got 1.99 ether, and I can send you guys ether on there. So you guys have just received real DOINK coin. And what's kind of cool about it is you can actually look up the smart contract on the blockchain. So if you can say like, this is the contract, right? And you can actually see the transfers and who was sent what sort of when. So you can see someone transferred this to so-and-so, and I think like the amount of DOINK is even in here too, like how much you're actually sending, which is kind of cool. So yeah, no, you guys are mad rich now. I'll put test ethers in all your wallets too really quickly here. I'll show you how that works. So let me go back to the faucet and get more. Your gray listed. Gray listed appears next to an IP for address. What? Gray listed? Go fuck yourself. Okay, I mean, fair enough. I'm kind of stealing your shit. Fair. ADC's good. Oh, ADC. You got to get the wallet, dude. You got to sign up for MetaMask. We got to get you on board, buddy. Big entry in the chat here. We're giving out free DOINK coin today on the Ethereum mainnet. So if you want to grab yourself a MetaMask wallet, it's a Google Chrome extension. You can find it here. It is awesome. Install that in your Google Chrome. Send me your Bitcoin address, and I will send you crazy DOINK coin to be part of the meme. So let's send you guys, just for funsies, I'm going to send you guys all Ethereum. So technically, like, just so you guys understand, this is like, what, $6,000, I think, in real money, or in fake test money. So yeah, six grand. So it's more than enough to pass around. So I'll do a little sharing here. We'll send to, where's my wallet? Perfect. Oh, I need Matt's wallet again. I want to keep these on file so I can keep sending you guys fun stuff. So let's start with Matt. We're going to send you, I don't know, 0.25. Sorry, 0.25. Perfect. Next. Confirm. Boom. Got it. J. Send 0.25. Next. Send. And Pat. Oh, wow. I gave out more DOINK than I probably should have. Just saying. Just saying. I don't, how much did I give you guys? I gave you so much DOINK. Like I'm more than half the supply. I think on the test network I gave Jay or someone way too much DOINK when I just hammered in a bunch of keys. Because there's there was 6,000. It's a guys. What is your current DOINK balance? That's really what I want to know. Send your. Oh yeah, no, Jay's got 500,000. Oh, sorry, that's the real one. I keep mixing up the networks. That's why. I just told my boss that I quit. I sent him a photo of my channels. Oh, you'll love to hear it. Pat, I'm going to send you fake ether here. Hold on a sec. Cool. So there you go. You guys got ether coming your way on the test network. So you can play it like that's probably the way. Yeah, the 0.25 ether is in the test. So what I suggest doing is that if you're going to use this for any kind of training, you guys play around on the Robson test network, and that'll make it easier for you to do it without actually having to invest any real money. If you do want to invest real money, then that's where you use the real DOINK coin that's on the main net. Where is... You could use some more. Matt, what's your current balance? Send me a screenshot of what your wallet looks like right now. Are you able to change the image of the token? So I don't think so. I should have. There is. So what I was going to show you guys, and this is where, like, I don't know, money is involved. It's called wallet builders. So, okay, so Matt's got 300,000. So one of the things we could actually create a real coin that isn't a smart contract, and this thing lets you do it, but I've tried it before and it just never works. They want a 70 or 80, sorry, yeah, 70 euros for the paid one that gives you a custom logo. So I'm not too sure how the logo thing works, to be honest with you. It would have to be like embedded in the contract or like in like a GitHub or something where they're pulling that from. How do you get this DOINKs onto my... Okay, so on your test network, I can send you test DOINKs. because that's where I think all the fun is at. I think that's where the fun is going to be, guys, to be honest with you. So let's send Matt Doink. And we'll send him 1,000. Okay. Boom. Okay. So once this transaction processes, and again, I can go here, and if I really wanted to speed it up, I can say, yeah, give me the fastest speed up you got here. Interesting. Sick. So that is, guys, that's the short and skinny. Cool. Transaction confirmed. That looks like it went through. So Matt, you should get test doink here in a second. Let me know if you get that. Pat, how much doink do you have on the test network? And Jay, I know you've got 500,000, I think, in the other one, but do you have test? Pat's got 500,000 test. Okay, good. No doink on test. Okay, let's give you doink on test. Send. Oh, the difference is super simple, Pat. I'll show you. Just give me 1 sec. So what you do is if you go to MetaMask, if you're looking at the actual, let me close the thing so you can see what the widget looks like. So if you click here, right at the top, this little thing here will say the Ethereum mainnet, which is your actual production guy. And then if you switch over to the Ropsten test network, that's where the test doink and test money is. So you should have a little bit of Ethereum in there plus some doink. You may need to add the token. I'm not super sure if that... Okay. Try adding the token again, Pat. See if that works. And this is the contract. Why do you see? Because I was fucking around. Because I was messing around. Because you can make as many smart contracts as you want and call them the same thing. I'll show you guys what it actually looks like. So, you know, if I want to make another one of these on the fake blockchain, I'd go to remix.ethereum. I would take this code. How about we'll make a new one? Just for shits and giggles, guys, we'll make our own new. Go here. Go here. And we're gonna build it together, okay? Real quick. It's gonna be super fun. I promise. New file. We're gonna call it. So what's the new? Oh my god! Did I give you 20 million? Is that 20 million? That's amazing. That's a good amount, Pat. That's a good amount. As you can tell, the doink process in calculating how much you guys get is it did not add the zeros. Oh, you think he got your test doink? Oh no. Okay. That's fine. We have, guys, the good news is we got so much doink to give away here that really it's just not a problem. There's still quite a bit. So we're gonna send J doink. Oh, gotta make sure I send the right doink, and then we'll send him, I don't know, 3 that. Next. Confirm. Perfect. See what happens there. My address is here. I'll send, this is my wallet's there. Okay, so what I was going to show you guys is how do we create a coin? So first off, can I get some names? We need to come up with a new name for our coin. So what are we going to call our coin off the top? Doyoi. Okay, I actually kind of like that. Doyoi. So we'll call it DOIYOI. Now we need a... What's going to be the name? The symbol should be... It needs to be small. It needs to be short. DOI. Let's call it DOI. What is the total supply of our coins? So how many coins are we going to actually be able to make? I think we'll leave the number as whatever that is. It is going to be deployed to Mark's wallets, which is here. So we put that address in here. Perfect. DOI, a lot of coin. Actually, you know what? No, we're going to do it this way. It makes more sense. Okay, cool. So we take this code. We're going to call it a new file. We're going to call it DOI, like that. Dank coin's already out there though. That's the problem. Someone already made dank coin. Sorry to burst the bubble, boys. So now we just quickly update a couple of attributes. So we call it DOI. And then we're gonna need this. So DOI is here. This is the symbol. This is the name. This is the supply. This is the wallet address that it's going into. Okay, it's really all we need to do. Everything else is already there for us, which is awesome. Okay. So DOINK doesn't seem to show in the transaction history. That's interesting. I'm not sure why that would be, but you know. But you still have it, right? Like it's still like is it showing up in your wallet at least, Jay? So, what Solidity is a essentially like a programming language for Ethereum, and Remixed ID is a platform that lets you develop inside of it. So now what I can do is I can actually take this over to the compiler. So the compiler takes all of this code, and from this code is able to generate the files required for a smart contract. Okay. So I'm going to click compile DOI, and it is actually going to say, okay, cool. The contract is there. DOI. It's done. It's been created. So I can move on to the next step, which is actually deploying and running transactions on the Ethereum net. So in order to do that, I want to link it to my wallet like we talked about before. I'm on the test network, which is ideal, right? I am going to choose the contract that I want, which is the DOI, right? These are all components of the contract, right? The safe math, who owns it, blah, 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 blah. I think to a certain extent, we can actually go into some of this stuff and like edit things and put, you know, some of our own fingerprints in it, but we're not going to do that for the sake of this demonstration. Okay. So we are going to say that this is the DOI coin. Okay. We are going to use the injected Web3 methodology because, again, that's going to connect to the Chrome extension that's connected to our account. The gas limit and the way this is going to determine how fast that it is put. So we're going to put 50, and we are going to click deploy. Now it's going to say gas error to the following message, blah, blah, transaction execution will likely fail. Why is it going to fail? Just maybe change this to 0. Whoa. I don't know why that's happening. There we go. Okay. So it's going to say, hey, Mark, in order for you to do this transaction, in order for you to create this coin, I'm going to want to spend this much money. And I can change this gas fee. Like I can lower it if I really want to. But the higher it is, or the higher the gas price, the faster the transaction will actually complete. Okay. So now I hit confirm. And what you're going to see is, a second, if this works, contract deployment, okay? When I click here and go to the actual Etherscan, I should be able to see this contract essentially in progress, getting ready to go. If I really wanted to, I could go back to here, and I could say, you know what, I want to speed this up. I want to dump more money into it. So save that, dump some ether, and boom. Okay. So once that is done, oh, did it already finish? Oh, shit, there you go. So now the DOI is deployed to the Ethereum network, and I can actually take this value, which is the contract value. I can go into here. I can click add token. You'll see that it automatically populates like you've seen before. By the way, guys, you can add the token now to yours if you'd like, because now you can send DOINK coin. So I'm gonna hit next, and there you go. Now I have these tokens in my wallet, and I can start sending them ad nauseum to my friends if I wanted to. So let's do this. Let's go here. We will expand the view. We'll go to our DOINK coin. So I think, what is that? Is that 69 million, I think, or something like that? Yeah. Sorry. 690 million. Okay, cool. So we're going to give everybody 100 million. Perfect. Awesome. Everyone's getting 100 million right now. So send to Matt. And we're going to send that much. Boom. Next. And then J. Okay. Send. Boom. And then Pat. Send. Pat. Perfect. This is all test network. This is all on the test network. Because again, it would cost deploying a smart contract actually costs like $30 in gas and stuff, because of the computational work that goes into it. You really have to incentivize the miners to add it to the blockchain. So, honestly, as someone who works like in tech, I have a very hard time even so there's gas and gas price. Maybe we'll watch a video on it and see if we can't get that explained a bit better, because even I have a hard time articulating it. Essentially, the idea of gas is, if they use the analogy of an engine a lot. So the amount of gas that you can put into it is the size of the engine, and the price of gas is the price per unit. So the more gas you have, and the higher the gas price, the faster your transactions will go. No, gas is like it's internet. It's like it's a concept specific to the Ethereum blockchain. So let's actually look that up. What is gas and gas price in Ethereum? Watch a quick little video here. Try and find one that's not fucking brutal. Sure. This is off the Ethereum site. Oh, okay. So yeah, here you go.
What is Ethereum gas? To run your car, you need fuel. To run an application on Ethereum, you need gas. The gas mechanism makes Ethereum extremely efficient at allowing scarce resources on the network. Everything on the Ethereum network costs a little bit of gas, including transactions. Gas on Ethereum has a market price determined by demand for resources on the network. The amount of gas you need depends on how large of a contract you're trying to execute, and how fast you want it executed. If you are willing to wait longer, you can pay less gas. If you want your contract or transaction executed faster, you pay more gas. Many functional tokens today have taken efficiency ideas from the Ethereum gas market and applied them to problems in other industries. Many believe the future lies in this kind of very efficient use of decentralized resources, which benefits all participants.
So there you go. That's essentially the concept of gas. So gas is what the entire network runs off of, and in order for you to transact, you must pay a little bit, which is why using the test network, right, is a lot better than using the live network necessarily for DOINK, because then we can really play around with it and just send money like ad nauseum, right? But I could actually take this token, for example, if I didn't want to look at it anymore, and just say, you know what, just hide that. I don't want to see it. Boom. Cool. So now I've got my coins. Been able to send you guys out some stuff. Pretty sick. Pretty sick little fun little exercise, guys. I think everyone on the chat so far has gotten. I am gonna plug. Let's see here. Gotta shame these guys a little bit for perfect. Let's shame them into showing up. But yeah, guys, that's kind of the essential idea behind minting together a smart contract. You can really do this anytime you wanted. Like if you wanted to, add value to something and be able to transact a token to sort of say like I own this, then you can do that on the Ethereum blockchain if you really wanted to. Or you could make a fake cryptocurrency to use for betting and fake paying for things for your friends. Just feeling like a Nigerian prince, just having an enormous amount of money at your disposal in order to just push your weight around, which is always super fun. So I think, if you guys want me to keep sending you money, just keep telling me and I'll keep sending DOINK coin, everyone. But I think we've kind of concluded the DOINK coin / minting piece of it. As more people come into the chat, I highly recommend. Wow, chat. There we go. Sean's asking a question. So we're gonna switch gears. Oh, so what's this?
We want more money. Yeah, more money.
More money
I
from
missed-
where?
Just more money, Canada doesn't get enough money.
'Kay.
Other countries have lots of money. We want some of that money. How about the internet? The internet makes lots of money, so give us some of that money. Yeah, give us internet money.
Mr. Bootman, you seem to not understand how global economics works. I think
Don't give me that fat cat fancy lip wiggling. Are you gonna give Canada more money or not?
There we go. Okay. I gotta do it, Jay. For that clip, Jay's getting another payout here. This is the best part about the DOINK, is that it's just so it can be handed out with such je ne sais quoi. Should make a little tutorial for those who want to get in while it's hot. Yeah, I guess that's not a bad idea. I mean, they can always watch. Yeah, you know what? Let's do that. So let's walk through actually the concept of making a brand new wallet really quickly, because I know you guys did it and it was fairly easy. In order for me to do that, I believe I need to be able to manage my extensions. So I gotta go here, manage extensions. I'm gonna have to go to MetaMask. I'm gonna have to remove. I'm gonna say remove this from my shit altogether. Now, I would actually be kind of fucked if I didn't write down all the information to get that wallet back. Like all of that money that I just put in and all of DOINK coin would basically be orphaned to the internet. So hopefully I can get it back. We'll see in a minute here. So we'll go to MetaMask extension, go here. We're going to click add to Chrome, add. It's checking. Cool. Welcome. Get started. So I could, if I lost my wallet, I could import it, but let's just set up. Okay. Now, again, guys, you never do this broadcasting on the internet. Like this wallet, I'm not going to use for anything for the specific purposes. But we'll come up with our test phrase. We'll broadcast all that on the internet and then kind of leave this wallet to go to the wayside. So let's click I agree. So we're gonna need a password. We're gonna call this password hey there guy. Why? Actually, no. I need to say hey buddy. Canada wants more money. Like that. Okay, create. Secure wallet. Before getting started, short video. No, I don't care about this. Reveal the secret words. So we're gonna grab this. We're gonna bring it over here. We're gonna do that. Next, and then we're gonna have to say, because it won't actually let you paste them. It wants you to click on each one and go through the whole thing. So it's gonna be fatal, and then it's gonna be what youth crop start cupboard ritual or rural, I should say. Sorry, rural brief. Bleh. Rich income reveal rabbit. Confirm. Congratulations, you set it up. Cool. That's it. We've created a wallet, and now I can send stuff to that. And if I wanted to go to the test network and copy this and put this here and say, I could send that money. I'm not going to, but and what I'm also not going to do is show you guys how I recover my wallet, but I am going to go through that process really quickly. So remove from Chrome, get rid of MetaMask, add it back, add the extension. Perfect. And I'm going to say get started. I'm going to import my wallet. I agree. Here's the secret recovery phrase, which I'm not going to show you guys. Okay, go here, and then password. Okay. Okay, that's cool. Sick. So if we bring this back over to the main menu, you guys will see, hey, that's about right. That's Mark's wallet. He had about $20. And if we go back to the test network, we should see, oh my God, where's the DOINK? Is the DOINK gone? Do I have to re-add it? Oh, I probably have to, yeah, that makes sense. I'd have to re-add all these tokens. So that is the actual contract token that we're going to put over here. I think I put it in the, I believe this is it here. So add token, token address, DOINK. Perfect. There you go. DOINK. And there's my balance. Add tokens, right? So it immediately knows how much DOINK I have. And then if you want to go back to the DOI, I believe I still have that somewhere in Remix. If I go here and I actually grab the transaction record here, I could bring that guy back in as well. Perfect. All right, tokens are back in the wallet, guys, and that's how we re-add our tokens. So we have massive amounts of DOI. Got a fair bit of DOINK still in supply. I think I've given out almost more than half of it somehow, which is just amazing, and I love to see. But what's fun is that now we can just like trade it like crazy, and hopefully get a couple more people onto the DOINK coin, which you love to see. Guys, I'm gonna take a quick 2-second break. Really what I'm going to do is grab an ice cream sandwich and just bring it back. I'm going to put on a little splash page, take a quick seat, lean back. We're going to be back in a few minutes with some fun and interesting, well, it's interesting to me, content. So bear with me for uno momento, por favor. And stick around, more prizes, more DOINK coin. You don't want to miss it. What a beautiful tune. Again, mad shoutouts to Rob Jansen for providing the mood, as always. All right, guys. I actually found a cool video where a guy walks through building a blockchain, and it takes all of the cryptocurrency stuff out, which I think is really helpful for understanding what blockchain actually does and how it works. It's pretty... Oh, actually, before we shift in that, let's watch a holy shit video for a hot second. This is a really cool 2-minute paper on how Google's new AI puts video calls on steroids. I actually haven't seen this yet. I heard it's pretty fucking interesting. So we'll dive in that, and then we'll talk a little bit more blockchain after.
This is 2-Minute Papers with Dr. Károly Zsolnai Fehér. With the increased popularity of online meetings, telepresence applications are on the rise where we can talk to each other from afar. Today, let's see how these powerful, new neural network-based learning methods can be applied to them. It turns out they can help us do everyone's favorite, which is showing up to a meeting and changing our background to pretend we are somewhere else. Now that is a deceptively difficult problem. Here the background has been changed, that is the easier problem, but look, the lighting of the new environment hasn't been applied to the subject. And now hold on to your papers and check this out. This is the result of the new technique after which recreates the image as if she was really there.
That's wild.
I particularly like the fact that the results include high-quality specular highlights too, or, in other words, the environment reflecting off of our skin.
That's crazy.
However, of course, this is not the first method attempting this. So, let's see how it performs compared to the competition. These techniques are from 1 and 2 years ago, and they don't perform so well.
I think this is going to be an interesting just like illustration of how quickly this technology is catching up in terms of its like capabilities and its ability to do things that are just going to change the world. Like this is the type of shit, like fuck deepfakes, man. Like deepfakes aren't even the problem. It's about like not being able to understand like the reality that you're even looking at anymore.
Not only did they lose a lot of detail all across the image, but the specular highlights are gone. As a result, the image feels more like a video game character than a real person. Luckily, the authors also have access to the reference information to make our job comparing the results easier. Roughly speaking, the more the outputs look like this, the better. So now, hold on to your papers and let's see how the new method performed.
Wow.
Oh yes, now we're talking.
Yeah, that's crazy.
Now, of course, not even this is perfect. Clearly, the specularity of clothing was determined incorrectly, and the matting around the thinner parts of the hair could be better, which is notoriously difficult to get right.
Interesting.
But this is a huge step forward in just one paper. And we are not nearly done. There are 2 more things that are found to be remarkable about this work. One is that the whole method was trained on still images, yet it still works on video too. And we don't have any apparent temporal coherence issues, or in other words, no flickering arises from the fact that it processes the video not as a video, but a series of separate images. Very cool.
Interesting.
2, if we are in a meeting with someone and we really like their background, we can simply borrow it.
Oh fuck, this is crazy.
This technique can take their image,
Get out of here. Like,
estimate its lighting,
and it's so funny that like my friend Sam, who's an artist, just showed up. Like just being able to appreciate like the difference in lighting and shadows, and how like, oh my god, that is actually quite creepy.
and give the whole package to us too.
What a cool pit
I
band.
think
Don't worry,
this
buddy.
will
We'll
be
catch
a
up
game
quick.
changer. People may start to become more selective with these backgrounds, not just because of how the background looks, but because how it makes them look.
Right.
Remember, lighting off of a well-chosen background makes a great deal of a difference in our appearance in the real world,
Hell yeah.
and now, with this method, in virtual worlds too. And this will likely happen not decades from now, but in the near future. So this new method is clearly
This is
capable
insane.
of some serious magic. But how? What is going on under the hood
Where's-
to achieve this?
What is the magic?
This
Show me the
method
spell.
performs two important steps to accomplish this. Step number 1 is matting. This means separating the foreground from the background, and then, if done well, we can now easily cut out the background and also have the subject on a separate layer and proceed to step number 2, which is relighting.
Right.
In this step, the goal is to estimate the illumination of the new scene and recolor the subject as if she were really there. This new technique performs both, but most of the contributions lie in this step. To be able to accomplish this, we have to be able to estimate the material properties of the subject. The technique has to know 1. Where the diffuse parts are. These are the parts that don't change too much as the lighting changes, and 2. Where the specular parts are. In other words, shiny regions that reflect back the environment more clearly. Putting it all together, we get really high quality relighting for ourselves, and given that this was developed by Google, I expect that this will supercharge our meetings quite soon. And just imagine what we will have 2 more papers down the line. My goodness, what a time to be alive! This video has been supported by Weights and Biases. Check out their recent offering,
Absolutely
Fully
wild.
Connected, a place where they bring machine learning practitioners together to share and discuss their ideas, learn from industry leaders, and even collaborate on projects together. You see, I get messages from you fellow scholars telling me that you have been inspired by the series, but don't really know where to start.
I love this guy's passion. Like, you can just tell the way he talks about like these papers. He's like, this is really cool. Like, it is very, very sick stuff. I don't want to go too far down the AI rabbit hole, but a lot of, I don't know, I guess I like a lot of science fiction stuff around how artificial intelligence will be implemented. We have traditionally thought of like robots or artificial assistants like in Her or personas or like an AGI that we'll talk to. And I don't think like AI is really going to have much of a role in our lives in that more, old or that more traditional or canon in terms of what we see in a lot of science fiction. I think what we're going to see a lot more is just the augmenting of our realities. Really, really subtle. Yeah, exactly. Like a complete realignment of reality based off of what typically would be post-processing that happens in like a Hollywood set will shortly be available right here, or at least between here and the cloud. Like there will be a substrate that's capable of essentially processing and chunking and applying like massive amounts of AI technology to change something. So like, and a great example is
Dear fellows,
no, this
dear
video.
fellow scholars, this is Minute Papers with Dr. Károly Zsolnai Fehér. This paper is called Enhancing Photorealism Enhancement.
Enhancing photorealism, and I love that title.
Let's try to unpack
great.
what that exactly means. This means that we take video footage from a game, for instance GTA 5,
I think some of you may recognize this, right?
which is
Yo,
an
what's up,
action
ABC?
game where the city we can play in was modeled after real places in California.
Right.
Now, as we're living the advent of neural network-based learning algorithms, we have a ton of training data at our disposal on the internet. For instance, the Cityscapes dataset contains images and videos taken in 50 real cities, and it also contains annotations that describe which object is which. And the authors of this paper looked at this and had an absolutely insane idea.
This is
And
crazy.
the idea is,
This is wild.
let's learn on the Cityscapes dataset what cars, cities, and architecture looks like, then take a piece of video footage from the game and translate it into a real movie. So
Right.
basically something that is impossible. That is an insane idea, and when I read this paper, I thought that cannot possibly work in any case, but especially not given that the game takes place in California, and the Cityscapes dataset contains mostly footage of German cities.
Right.
How would
Right.
a learning algorithm pull that off? There is no way this will work. Now, there are previous techniques that attempted this. Here you see a few of them. And,
Interesting.
well, the realism is just not there, and there was an even bigger issue.
Yeah, you can see like artifacts popping in and out. Like you can see like rendering mistakes in real time as you're shifting your perspective, you know.
And that is the lack of temporal coherence.
Right.
This is the
a great way
flickering
of
that
putting
you
it.
see where the AI processes these images independently and does not do that consistently. This quickly breaks the immersion
Interesting.
and is typically a deal breaker.
Yep.
And now, hold on to your papers
I
and
love-
let's have a look together.
Hold on to your
at the new
papers,
technique.
guys. Oh shit.
This is nothing like the previous ones. It renders the exact same place, the exact same cars, and the badges are still correct and still refer to real-world brands. And that's not even the best part. Look, the car paint materials are significantly more realistic, something that is really difficult to capture
Wow,
in a
that's
real-time rendering
crazy.
engine. Lots of realistic-looking specular highlights of something that feels like the real geometry of the car. Wow. Now, as you see, most of the generated photorealistic images are dimmer and less saturated
Look at
than the
that.
video
That's
game graphics.
insane.
Why is that? This is because computer game engines often create a more stylized world where the saturation, haze, and bloom effects are often more pronounced.
Interesting. Okay.
Let's try
okay.
to fight this bias where many people consider the more saturated images to be better and focus our attention to the realism in these image pairs. While we are there, for reference, we can have a look at what the output would be if we didn't do any of the photorealistic magic, but instead we just tried to breathe more life into the video game footage by trying to transfer the color schemes from these real-world videos in the training set.
Interesting. Okay.
So, only color transfer. Let's see. Yes, that helps until we compare the results with the photorealistic images synthesized by this new AI. Look, the trees don't look nearly as realistic
yeah,
as the
this
new
is
method,
crazy.
And after we see the real roads,
The
it's hard to
zero
settle
gross.
for the synthetic ones from the game. However, no one said that Cityscapes is the only dataset we can use for this method. In fact, if we still find ourselves yearning for that saturated look, we can try to plug in a more stylized dataset and get this. This is fantastic because these images don't have many of the limitations of computer graphics rendering systems.
This is wild. So, I don't want to get too far down the weeds in this video because there's quite a bit more to it. But, like, this is where the tech gets absolutely insane. And every year it's getting a little bit faster and faster and more capable of just producing outputs that... I mean, if you told me that we would be able to have like deep fakes and AI and like voice recognition like this good, like voice recognition when I was young was basically like, oh, that's we're never gonna have good voice recognition. Like, there's no way. Like, it's a very difficult problem to have, and no one's ever been able to figure out. No one's ever gonna figure it out. And when you look at how well like Siri and Google Assistant work in comparison to like the old Dragon word, there used to be a program. I think it was called like Dragon Voice Reader or something that would help you do like talk to text for a PC like pre-2000s. But this is like what, you know, and this is how AI is going to be playing like more and more of a significant role in our day-to-day lives, whether it is enhancing the imagery that we see, whether it's augmenting reality with information that could be useful to us or valuable to us. And where it gets weird though, and I think for some of you who have been on the channel before, there's a really fun video that illustrates how AI sometimes behaves in ways that like we really don't understand why it does what it does. Let me see if I can find this. It's a great little example of... 2-minute papers. It's not this one. It's one that we've watched before. The reason I want to show you guys this is it's fucked because it shows that like AI can demonstrate some incredibly emergent behavior, and not only emergent behavior, but behavior that's like just straight up like unexpected, and it will do stuff that sort of like breaks the simulation, if you will. That's a great one too. One sec. I swear I had this bookmarked at some point, but I have no idea where it is. Oh, no, this is it. Okay, here we go.
Dear fellow.
So this one's not too long. Some of you may have seen this if you watched on previous streams, but I think it's like just a great little reminder of like how cool these experiments can, like, or cool shit that these experiments can show us about these behaviors.
In this project, OpenAI built a hide-and-seek game for their AI agents to play. While we look at the exact rules here...
By the way, one cool pigman, is that MetaMask wallet up? We got some... for those of you who were just tuning in, we went through the process earlier of creating some cryptocurrency, and as a result, we've minted a coin. We've minted a coin on the Ethereum test network called DOINK, and we'll be giving that out. So if you want to sign up, get yourself it's not even, you don't have to sign up, it's just creating a wallet using MetaMask and Google Chrome. Send your address in the chat, and we'll send you DOINK coin on the test network to start.
I will note that the goal of the project was to pit two AI teams against each other and hopefully see some interesting emergent behaviors. And boy, did they do some crazy stuff. The coolest part is that the two teams compete against each other, and whenever one team discovers a new strategy, the other one has to adapt. Kind of like an arms race situation, and it also resembles generative adversarial networks a little. And the results are magnificent, amusing, weird. You'll see in a moment. These agents learn from previous experiences, and to the surprise of no one, for the first few million rounds, we start out with pandemonium. Everyone just running around aimlessly. Without proper strategy and semi-random movements, the seekers are favored and hence win the majority of the games. Nothing to see here. Then, over time, the hiders learn to lock out the seekers by blocking the doors off with these boxes and started winning consistently. I think the coolest part about this is that the map was deliberately designed by the OpenAI scientists in a way that the hiders can only succeed through collaboration. They cannot win alone, and hence they are forced to learn to work together, which they did quite well. But then something happened. Did you notice this pointy, doorstop-shaped object? Are you thinking what I'm thinking? Well, probably. And not only that, but about 10 million rounds later, the AI also discovered that it can be...
So, just to stop for a second, just to focus on what you said, 10 million rounds later. So, the only way that what we're seeing is a visualization of the game, and obviously it takes like millions and millions and millions of iterations for these little AIs to play for, you know, some subset of time. But it has to go through millions, if not billions of iterations before it actually becomes successful. But the way that it's able to become successful is it can learn. It can remember what it did last time that was, you know, a successful strategy or worked for it, and build off of that, and then change, you know, its actions to, you know, try more of that or try different permutations of that. And that's kind of where the real power of AI is that it can iterate on itself billions of times faster than we as human beings can, and like back propagate that data to grow off of it.
Be pushed near a wall and be used as a ramp, and ta-da!
Boom.
Got him. The seekers started winning more again.
So they figured out they could use the
ball
ramp
is
eventually.
now back on the court of the hiders. Can you defend this? If so, how? Well, these resourceful little critters learned that since there is a little time
That's crazy.
at the start of the game when the seekers are frozen, apparently during this time they cannot see them, so why not just sneak out, steal the ramp, and lock it away from them? Absolutely incredible. Look at those happy eyes as they are carrying that ramp. And you think it all ends here? No, no, no. Not even close. it gets weirder. Much weirder. When playing a different map, a seeker has noticed that it can use a ramp to climb on the top of a box, and this happens. Do you think couch surfing is cool? Give me a break. This is
Give me a
box
break.
surfing. And the scientists were
awesome.
quite surprised by this move, as this was one of the first cases where the seeker AI seems to have broken the game. What happens here is that the physics system is coded in a way that they are able to move around by exerting force on themselves, but there is no additional check whether they are on the floor or not, because who in their right mind would think about that? As a result, something that shouldn't ever happen does happen here. And we are still not done yet. This paper just keeps on giving. A few 100 million rounds later,
Okay, so we're gonna pause here for a second. Neil, you got your wallet. Okay, so if you can see my screen, I'm gonna show you what you need to do with MetaMask. So, in order, what you missed earlier in the lecture was that for us to do this in the real Ethereum blockchain, it costs actual money. But what we actually can do is use what's called a test network. So when you finally get into MetaMask, into this extension here in your browser, at the very top, you're going to see it's the Ethereum mainnet. You're going to click on the arrow, and you're going to choose the Ropsten test network. Once you get to there, you're going to click on your address, your little right here, and you're just going to paste it into the chat. Once you pasted that, I can show you how to receive your DOINK coin. Just pull up our little ledger here. So we're going to add Neil. I don't know. We'll give Neil 10 million, I think, is a good number to start for showing up tonight. Okay, while you're doing that, I'm gonna put on this little interesting video.
So we've been experimenting.
Whoa! I'm so sorry. If you have ear holes that I just blew out, that's extremely unfortunate. I'm so sorry. Sometimes, streams are risky though.
There's a core concept in machine learning called high-dimensional space. Here's one way to wrap your head around this concept. You can think about people as being high-dimensional. For example, take famous scientists. You can think about when they were born, where they were born, their fields of study. Each of these is like a dimension of that person. Perfect. These dimensions become difficult to untangle when you think about different people, because someone might be similar in some ways, but very different in others.
But this is the kind of thing you can use machine learning for. With machine learning, the computer isn't told the meaning of these dimensions, it just sees them as numbers. And it sees each set of numbers as a data point. But by looking across all of these dimensions at once, it's able to place related points closer together in high-dimensional space.
So we're going to take a quick pause here because Neil has sent his fucking address, which is sick. So we're going to send you on, again, make sure you're on the Ropsten test network. I am going to send you a bunch of DOINK. Okay, perfect. Now, perfect. Once this transaction is complete, I'm gonna have to send you the address of the contract, because that you'll need to click add token, and then that'll actually give you the token selection here. So one sec. So, transaction confirmed. I think we're good to go here, guys. So if you go to your assets, you're gonna click on add token. And from there, you're going to paste in what I put in the chat. Nope, not that. Not that. One sec. Oh, there we go. That's it. You're going to paste this into the token contract address, and you're going to see DOINK is going to show up automatically, and this is going to set to 2, and then you just hit next. Okay, so go through that, paste what I just put in the chat under custom token. So add token, custom token, paste, Bob's your uncle. Okay. Looks like for those of you who are not here before, you can track all your transactions, obviously, and see what goes through to who when. I recently sent this. You can go to the test network. You can see it was successful. Who, blah, 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 for 100 million DOINK coin that just went to my friend, One Cool Pickman. So once he adds that token, it should show up in his wallet. And you are wealthy. You still need you need ether in order to actually transact with our friends, and we can get test ether on the test network. So what I'm also going to do here is send you some test ether. I got to make sure I put your wallet in my master spreadsheet here. It's not even a spreadsheet, but and so if I go here, I'll send you 0.25 ether. This should get you through more than enough transactions. That will just show up in your wallet. You don't actually need to do any kind of whatchamacallit. You don't need to do any kind of adding of tokens or anything like that. This is sick, guys. It's becoming a good time to start shutting down the tech talk, unless there's any other topics that chat wants to hear about, talk about. Is there anything that you guys are super stoked to get into before we conclude tonight's? Because there's some, I'm not going to lie, there's some serious Call of Duty ganging activity going on, and I kind of feel like I'm going to miss out on a really, really great win if I'm not careful. Oh, wow. Neil's posted his DOINK transaction. That's amazing. That is amazing. Extremely, extremely wealthy. Before we conclude tonight's stream, there was a video that I actually wanted to show you guys. That was kind of cool. This nerdy guy.
Dear fellow scholar.
Nope. Oh, yeah. We're going to watch a super quick video that actually explains what blockchain is independent of, like, cryptocurrency, okay? And if there's anything that you guys need me to clarify along the way, let me know.
What hashes are, and you need... Hey, what up guys, welcome back to my channel. And today I have a very special video for you that I think many of you will enjoy, because we will namely be building a blockchain in under 15 minutes. Because I want to demonstrate to you guys that blockchain in itself is a very simple concept. It's a very simple data structure at its core. Of course, cryptocurrencies are complicated, but the blockchain is not the reason they are complicated. The reason why they're complicated is the consensus algorithm, it's the mining, it's the transactions, it's everything that is around. But blockchain in itself is very easy to understand. What you need to know before you can actually understand what blockchain is and how it works, you need to know what hashes are, and you need to know how they work. And so a hash is basically a digital signature of some kind of data. So for example, I can take a movie and I can hash it and get a digital signature. I can take an email and I can hash it and get a digital signature. I can take a word and I can hash it. I can take a whatever data. You just take it, you hash it, and you get the digital signature for that data. So before we start with the actual blockchain, let me just demonstrate it to you how this works. So we will be building our blockchain in Java. It will be very simple, and if you know programming, you can do it in another language, and if you don't know programming, I think you still will be able to understand roughly how this works. So let's talk about hashes. As we can see, guys, we have two lists. We have one list that contains A, B, C, and we have a second list that also contains A, B, and C. So this is the data. This is basically the strings we're trying to hash. So let's see what kind of what kind of digital signature we will get from list 1, and what kind of so we will just print the digital signature or the hash. Whenever you hear hash, guys, you can just think, you can replace hash with digital signature. So let's see what kind of output we get if we print the digital signature of A and digital signature of list 1 and digital signature of list 2. So as you can see, guys, we get these two numbers, and the digital signatures are identical for these two lists. If I now change anything in list 2, for example, and I run it again, you see that I get a completely different digital signature. So if I just make a small amendment, I just meddle with the data, I try to change anything in this list, I will get a completely different digital signature. And that is the foundation of a blockchain, because a blockchain is a list of blocks, basically a chain of blocks, and each block holds the digital signature of the previous block. And the digital signature of the next block is based upon the digital signature of the current block.
This is the most important concept in cryptocurrency to understand, is the blockchain. If you imagine this like a physical chain, right? The strength of the metal is essentially determined by the hashes that are sticking together, right? So one hash feeds into the next hash, feeds into the next hash, feeds into the next hash. If you break any of those hashes, the entire chain falls apart, because it's impossible to like go back in the transaction, change the hash of something without it propagating up the entire chain, hence blockchain.
So they are all based together. The next signature will be based on the current signature, and the current signature is based on the previous signature. So if you change anything back in the past, you will break all of the signatures. They will look completely different. And I'm trying to adjust the lighting. I should get some kind of artificial light so I don't need to
It's funny, I like it.
to the current of itself. And this hash will be based on the transactions and the previous hash. So if anyone would change anything in the previous block, the digital signature of the current block will change. And when that changes, the digital signature of the next block will change. You will see how this works very soon, guys. So let me just remove this class that I played around with earlier. Let me see, delete. And let's start from scratch, and we will create a new class, and it will be the block. So I'm doing it in Java. You can do it in whatever language you want. It's basically simple stuff. So let's create the fields. It will have the previous hash. It will have the let me see. It will have the previous hash, and it will have the transactions, list of transactions. So I'm just making an array of strings. So each transaction will be a string in this case. Of course, in a real blockchain, the transactions would be their own objects, and we will need to create a object for that and define a class and all of that. But we're just playing around. Let's just create them as strings. So, and each block will also have its own hash, and this hash.
So I'm not going to get too deep in the weeds on the whole programming piece of this, but it's a really great video that illustrates like essentially how the chaining of these blocks happen. And so, you know, the entire technology that underlies, I shouldn't say the entire technology that underlies, so what are the critical aspects of how cryptocurrencies work is using the blockchain. The other piece is cryptography in general, which I've previously done a video on that's like kind of all over the place, and I should maybe do a second round of that's a little bit more coherent. Speaking of being coherent, I think it's time to wrap things up tonight. It's been a super fun stream. Really enjoyed minting DOINK coin with you guys. Keep sending me your wallets if you guys have watching this not live. I will keep sending out DOINK coin to whoever wants it. Thank you everyone for coming and saying hello and chatting or just lurking. I truly do appreciate it. It's great to see everybody, and yeah, I'll catch you guys on the flip side. Be well, everybody.